So let us continue by describing one of the most popular programming mechanisms or programming models that are used in both distributed systems and in parallel programming, the producer consumer, sometimes also called the bounded buffer problem. And this is a very simple problem where you have a producer that produces some amount of data and the consumer that consumes the data produced by the producer. The producer pushes the data into a buffer, uh, and the consumer consumes the data from the buffer, which is as simple as it sounds. Is actually a very common programming model that you would use in many cases. It's like singletons and many of these uh, programming uh, tricks that you would use basically to enhance your program. So in its simplest form, let us basically think about the simplest form of this program, where you basically the producer produces a single integer, and the consumer consumes that integer, and that where the buffer can only store a single value. So the buffer, in this case, has only one single value and no more. You can, of course, extend this to be more general, basically having the producer producing stuff that is stored in some memory location, passing a pointer through the buffer, and the consumer consuming that pointer. You can think of it as basically multiple elements being produced, and all of them are buffered in a queue. And as any and multiple consumers exist, and these multiple consumers basically consume the different data. This is actually how most web servers are implemented, like Apache, for example, where you would have lots of requests coming to your Apache web server stored in some buffer, and then consumers are basically threads that run and basically operate or service these requests that came. So, but let us basically start with the most simple example we can think of, which is basically single value, single integer being consumed and being produced. In this case, your basically put method, your put function, which is used by the producer to feed the buffer with data, will can look like this basically, where you initialize the buffer with an integer. Since it will store a single value, then you can have an integer. I mean, in other cases you might have basically an array, or depending on the programming language you might have a list or something, uh, and a count. And the count basically is how you keep track if there is data in the buffer or there is no data in the buffer. And this is basically, both of these variables are shared between both the producer and the consumer. And then the producer will do something like this. It will put an integer value, assert first that nothing is into the buffer, count is equal to 0. Basically the buffer is empty. Then it sets the count to 1, and then the buffer is equal to the value, so it stores the value into the buffer. Now if count is not equal to 0, then this program will just break. This put it will exit from put basically, and you can have a loop, of course, waiting for count to be equal to 0, because in this case we said that the buffer size is just 1. Get will basically start by asserting that the count is equal to 1, basically signaling or signifying that, well, you have data in the buffer. Then it will set the count to 0, and then it will return the buffer value. And of course you want this to be atomic. So this is basically the buffer.put and the buffer.get functions that we were just discussing. So one simple implementation for the producer and the consumer can look like this. I mean, we have looked at the put and get. You might have basically a producer that takes some arguments, and these arguments are basically the data that you're going to store in the buffer. So you basically initialize an integer with I. You basically cost in this case you cost into loops into a single integer, and you basically